Dear friends, I am Dr. Bakul Jayant Parekh. I have been the National President of IAP 2020 as well as Secretary of South Asia Pediatric Association for 2019 and 2020. I have also been recently appointed as the Global Academic Convener for GAPIO. Last year, I launched the IAP program under my Presidential Action Plan at IAP, through which we conducted over 1,700 events with a combined viewership of more than 2 million in the last few months itself. The events covered all areas of pediatrics and all the subspecialties. This particular session covers three very important topics related to the recent developments in pediatric field. We have three prominent and highly sought after speakers for today's symposia. The first talk is on COVID-19 implications for the future vaccine research and development by none other than Dr. Sanjay Gurunathan. Dr. Sanjay is head of the clinical development of Sanofi Pasteur in USA. The session will be chaired by Sunny Kurian from UAE. The second topic is probiotics in health and disease in newborn by Dr. Sanjay Patole from Australia. Dr. Sanjay is the National Director of KEM Hospital for Women at Perth, University of Western Australia. The session will be chaired by Dr. Ramesh Mehta from UK. The third topic in the symposia is a talk on short stature in children by Dr. Senthil Swaminathan from UK. Dr. Senthil is consultant pediatric endocrinologist at University of Liverpool, UK. And this talk will be chaired by Dr. Jayesh Tuteja from India. Let me tell you, viewers, that you are encouraged to type your questions in chat box with your email ID, and reply will be sent within 1 week after the conference is over. Now I invite Dr. Sunny Kurian to chair the first session. Dr. Sunny Kurian is a specialist A category pediatrician from UAE. He is also the chairman of Dr. Sunny Healthcare Group, and along with being the CEO of Health to Home in Sharjah. And he is also an immediate past president of Association of Kerala Medical Graduates at Emirates. He is also the founder president of Indian Academy of Pediatrics Emirates chapter and chairman and member of board of patrons of Indian Business and Professional Council at Sharjah. Dr. Sunny is also the founder trustee and governing board member of India Trade and Exhibition Center, as well as the founding member of Indian Business Leaders Forum. Dr. Sunny is the international co-convener of President's Council of GAPIO. The third topic in the symposia is a talk on short stature in children by Senthil Swaminathan from UK. Dr. Senthil is consultant pediatric endocrinologist at University of Liverpool, UK. And this talk will be chaired by Dr. Jayesh Tuteja from India. Let me tell you, viewers, that you are encouraged to type your questions in chat box with your email ID, and reply will be sent within 1 week after the conference is over. Now I invite Dr. Sunny Kurian to chair the first session. Dr. Sunny Kurian is a specialist A category pediatrician from UAE. He is also the chairman of Dr. Sunny Healthcare Group, and along with being the CEO of Health to Home in Sharjah. And he is also an immediate past president of Association of Kerala Medical Graduates at Emirates. He is also the founder president of Indian Academy of Pediatrics Emirates chapter and chairman and member of board of patrons of Indian Business and Professional Council at Sharjah. Dr. Sunny is also the founder trustee and governing board member of India Trade and Exhibition Center, as well as the founding member of Indian Business Leaders Forum. Dr. Sunny is the international co-convener of President's Council of GAPIO.
Thank you, Dr. Bakul. It's now my pleasure to introduce Dr. Sanjay Gurunathan. Dr. Sanjay Gurunathan is a physician based out of Bethlehem, Pennsylvania, in the United States, and he has done his specialization in internal medicine, particularly infectious diseases. He graduated from the University College of Medical Sciences in 1989, after which he has primarily worked with the Global Clinical Sciences Unit at Sanofi Pasteur in Bethlehem, Pennsylvania, United States, which he heads currently. His is a very impressive CV. He has over 18 years of global vaccine development experience in Sanofi Pasteur, with the primary responsibility to ensure the effective, timely, and robust design and management of the Sanofi Pasteur vaccine programs. He is given the responsibility to oversee the phase 1 to 4 clinical trial activities for novel vaccine targets, as well as supporting vaccines life cycle management and epidemiological activities worldwide. He plays a key ambassadorial role by representing the company within the medical research fraternity throughout, with the involvement in international scientific meetings as well as through professional publications. He has, to his credit, authored over 50 publications and has presented in large international meetings as well as including plenary sessions. It is my privilege to hand over the mic to Dr. Sanjay Gurunathan for his talk. Over to you, Dr. Sanjay Gurunathan, for your talk on newer vaccines. You have 8 minutes to deliver your lecture. Thank you.
Hi, good morning to you all. I wanted to thank Dr. Parekh for a very kind introduction, and also the organizers of GAPIO to give me the opportunity to talk today. My name is Sanjay Gurunathan. I'm the head of clinical development at Sanofi Pasteur, and I've been developing vaccines for over 3 decades. I'm here to talk to you today about COVID-19 vaccine development, not so much about the COVID vaccine development per se, but how and what we've learned from this process, this journey that we've undergone over the past year, and how that might affect the development of future vaccines. Just to give you a perspective of where we are today in 2021. We now have a successful vaccine just under a year into the pandemic. Let's put into perspective how remarkable that is. This is a slide that gives you a historical perspective of how long it took to develop vaccines for the various pandemics we have experienced over the past century. In the early, about 100 years ago, technologies were not there. It took a couple of decades to develop vaccines. But what emerges from looking at this chart is that if we are hit with a new pathogen for which we don't have an established vaccine platform, it takes a long time to develop a vaccine. For COVID, we were able to do this in less than 1 year. So what did we do so well? What can we learn from this journey? And how can we apply it to other vaccines? If you think about vaccine development as a mathematical equation, and you think about how you can speed up the process, you need to understand all the inputs that go into the process, such as technologies, partnerships, clinical trial infrastructure, manufacturing, delivery, funding, policy, regulatory considerations, epidemiology, etc. And then you weight them accordingly. In order for you to achieve speed, all these inputs and the weighting need to come together in cohesion to be able to gain maximum efficiency. We did that for COVID in less than 1 year. Normally, it takes about a decade or longer to develop vaccines. So let's put that a little bit into perspective and specifics. Here on this table, on the left side, you see a column of how long it takes typically to develop a vaccine. And if you go through the various stages of vaccine development, whether it's preclinical, phase 1, 2, 3, or the approval phase, and you total up the rough timetables, and these are just generic timelines I've put in there, it takes about a decade. Now, this is what we've done for COVID. Everything has been remarkably accelerated. Preclinical phase lasting 6 months, the clinical development lasting another 6 months, being done in parallel, and the approval even happening faster. So what did we do right? And what can we learn from this? And how can we take the learnings and replicate it for other vaccines? In order to do so, we should understand what the key drivers of our accelerations are. So I've listed 5 key drivers that we've learned through the COVID process. As a scientific community, we've been we've readily accepted advanced technologies and applied them. We've applied very effectively newer digital technologies. Our product development plans have been very streamlined, as have been our manufacturing and supply plans. And the world in general has come together with broad-based collaborations with funding mechanisms to really accelerate vaccine development. So let's go through some of these drivers. We've done a very good job of applying advanced technologies to enable vaccine development. Sequence and antigen design has happened. The virus was sequenced in China. Quickly, the sequence was transmitted all around the world. The antigen was designed. Everybody is using about the same antigen. We applied automation, improved diagnostic for clinical endpoints, data management, analytical techniques. A lot of advanced technologies came together very quickly to enable faster vaccine development. Digital applications also came through together, and the scientific community accepted them readily in order to accelerate development. Here's some examples of how of the things we use, the digital technologies we use to enable vaccine development. Now, each of these is a lecture by itself, but I just wanted to keep it high level and summarize for you. And these technologies included applying large computer algorithms to make predictive epidemiological models to help with clinical trial enrollment, data collection in clinical trials, real-world data for recruitment, and then, of course, being ready to accept vaccines for post-marketing studies and further learnings. The vaccine manufacturing sector was also accelerated. Normally, the process of vaccine development and manufacture is quite complex. It involves many steps. It involves a close collaboration with the regulators, release of the vaccine, labeling, inspections of the facilities. All these were done in a very rapid way with collaboration with various regulatory agencies to enable vaccine development. The clinical plans were streamlined. Normally, you do phase 1, 2, 3 in sequence. In this case, for COVID, we were able to compress phase 1, 2 into one study and then seamlessly move to phase 3 with a lot of acceptance from regulators, the regulatory process being simplified, all enabling rapid clinical development. The clinical development for COVID vaccines took 9 months, and typically for most vaccines, it takes over a decade. Not only did the manufacturers and the regulators and the funders come together, there was a much larger group, and new partnership models were forged, ranging from biopharma companies to government agencies to NGOs, public-public partnerships, public-private partnerships, all came together to help vaccine development. And all these learnings created broad synergies that are not only applicable for COVID vaccine development, but also can be readily extrapolated to other vaccines. Here are some examples of things we've learned from COVID that can be extrapolated to other vaccines. Modeling, digital technologies, we talked about that, availability of large clinical trial infrastructure sites to be able to test vaccines, regulatory harmonization, assay harmonizations. A lot of learnings came together. All this was done without compromising any regulatory safeguard, and that's really important to state. Although it gives the appearance of shortcuts, the regulators stood fast, and none of the standards were actually lowered to enable this fast timeline. So to conclude, the landscape of vaccine development post-COVID has changed. Development and benchmark milestones as we understand them do not hold true anymore. Do not hold true anymore. I take that back. Development milestones that we typically understand for vaccine development, which last over a decade, all have now been challenged. We've learned a lot from COVID, and I hope we can continue to leverage the learnings and apply it to other vaccines so that we can have more and better vaccines and improved vaccines to develop humanity in general. Thanks very much for giving me the opportunity to talk. I look forward to hearing feedback from the session. Thanks. Bye.
I thank Dr. Sunny Kurian for introducing the speaker as well as the speaker of the topic, Dr. Sanjay Gurunathan, for an excellent talk which conveyed the way COVID vaccine was developed rapidly using advanced digital technology, streamlined clinical product development plans, and controlling vaccine manufacturing and quality. This has created a pathway for rapid development of future vaccines. Now I will call upon Chairperson Dr. Ramesh Mehta. Dr. Mehta is a consultant pediatrician in UK. He is founder president of British Association of Physicians of Indian Origin, also known as BAPIO, as well as the immediate past president of GAPIO. Dr. Ramesh Mehta has been recognized by the Order of British Empire, the third highest civil award in the UK for these services under the National Health Services Program. Now I request Dr. Mehta to introduce the speaker, Dr. Sanjay Patole.
Thank you, Dr. Bakul Parekh. That is a very kind introduction. I am really delighted. May I also take this opportunity to thank GAPIO for giving me this very special opportunity to chair the session. Our next speaker is Dr. Sanjay Patole. Dr. Patole is a senior neonatologist at KEM Hospital for Women in Perth, Western Australia. Research of Dr. Sanjay is focused on preterm nutrition, evidence-based medicine, probiotics, prebiotics, prevention of necrotizing enterocolitis, and feeding intolerance in preterm infants. What an important area of research, Dr. Patole. I'm really impressed. Dr. Sanjay is a prolific researcher, and he has already published 216 papers. He has had over 4,000 citations and 33 H indexes. All this places him in top 1% of academic neonatologists. Dr. Patole, it's my pleasure to invite you to give you a presentation. Dr. Patole, please.
Before I start the session, I want to thank Dr. Bakul Parekh, the moderator of the session, Dr. Ramesh Mehta, the chairperson, and GAPIO as well. Today's talk is on probiotics in health and disease in the newborn, and we'll start the session now. The story of probiotics in preterm infants started in 2007 when a landmark meta-analysis came in Lancet. You could see on the screen it had 7 randomized controlled trials, about 1,400 babies less than 33 weeks, and significant reduction in the risk of necrotizing enterocolitis, all-cause mortality, late onset sepsis, and it facilitated the time to full feed with a reduction of minus 2.74 days. You could see the extremely impressive p-values. So this landmark publication in the Lancet started the story of probiotics in preterm infants in the current era. It specifically pointed out the unanswered questions. What is the optimal dose, duration? What are the optimal strains? Is single or a mixture of probiotics 10 better? Are live probiotics better or dead ones are preferable? So on and so forth. That the story started way back 13 years ago. Since then, basically the progress is in front of you on the screen. That in 2010, we published the first updated conclusive meta-analysis with trial sequential analysis that confirmed that the probiotic supplementation is extremely beneficial for preterm infants, especially those under 34 weeks of gestation. By 2011, we published evidence-based guidelines for the use of probiotics in preterm neonates. People had some question that preterm infants in low and middle income countries may not be benefited compared to those in high income nations. So 2017, we published a systematic review that confirmed that the benefits of probiotics for preterm infant in low and middle income countries are exactly the similar compared to what they are in the high income countries. People still have some questions that what is the science behind the benefits of probiotics? So 2018, we published a comprehensive systematic review and meta-analysis to confirm that probiotics reduce the risk and severity of NEC in various animal models of the illness as such. By the time it came to 2020, we had published a systematic review specifically focusing on India, and the meta-analysis confirmed that benefits of probiotics for preterm infants in India are the same as we had published earlier in low and middle income nations as well as high income nations. This is the most recent Cochrane systematic review. Remember that from 7 randomized controlled trials in 2007, we have gone up to 56 trials now, with total of 10,000 plus preterm infants. You could see that the risk of necrotizing enterocolitis is significantly less, and so is the risk of all-cause mortality, late onset sepsis, and the current evidence showed that there was little or no effect on severe neurodevelopmental impairment. And in terms of specific data on extremely low birth weight infants, there was not many trials, only 7 as you see on the screen, and there was no evidence that it affects on NEC, death, or late onset sepsis as such. So this is 2020 October Cochrane systematic review. Side by side, the new trend came to use the technique of network meta-analysis. So this is in front of you from 2020 August. This is now including 63 trials, 15,712 preterm infants, and what the results showed that multi-strain probiotics may be better than single-strain probiotic. In terms of the specific formations, combinations of Bacillus species and Enterococcus species, and 1 or more Bifidobacterium species and Streptococcus salivarius subspecies Thermophilus, quite a mouthful. So this is what this indirect evidence from the network meta-analysis showed that might be responsible for the largest reduction in NEC. But of course, this is still an indirect comparison because the way network meta-analysis works is quite simple. In the absence of head-to-head comparisons, all you could study that if everything else is okay, if A is equal to B, B is better than C, then indirect evidence means A is better than C. So this is the hypothesis on which network meta-analysis works. So it is still an indirect evidence. So the real answer will come from head-to-head comparisons of different probiotic strains and products. This is where we just finished our work, I think just last month or so. This paper is due for publication very soon. So this is about systematic review of non-randomized controlled studies. That means studies reporting benefits of probiotics compared to what the results were before implementing probiotics. You could see that the sample sizes are quite massive. Probiotic group, 21,000 infants. Control groups who did not receive probiotics before the practice change, 56,000 babies. And you could see that there's significant benefit for necrotizing enterocolitis more than stage 2, all-cause mortality, late onset sepsis as well, and time to full feeds. Impressively, this time we have provided data on close to 4,500 extremely low birth weight infant who received probiotics as a standard prophylaxis, and you could see that there's a significant reduction in the risk of NEC. And if you take care of the 2 outlier studies which actually reported increased incidence of NEC after implementing probiotic, so that's something unusual that we don't expect. And the reasons can't be discussed today in just 8 minutes as such. But you could see that if you take those 2 outliers out, then the results in extremely low birth infants are extremely significantly positive. Odds ratio of 0.43 and a p-value p less than 0.00001. So this almost covers the important argument that there is not enough data on babies less than a kilo when it comes to routine use of probiotics as such. When we talk of reasonably well, slightly bigger and mature infant out in the community, then Dr. Pinaki Panigrahi's trial published in Nature Translation 2017 is extremely important. So here you got 4,556 infants more than equal to 2 kilos or more than equal to 35 weeks, otherwise well out in the community. They received symbiotic or a placebo and monitored for 60 days as such, and they found that there was significant reduction in sepsis and death. You have the result in front of you with the odds ratio of 0.60. That's where the 40% reduction comes from. And the deaths were very small in numbers as such. Just 4 in placebo group died compared to symbiotic group, only 6 died. So this overall becomes significant, and it shows that for well infant out in the community, those who are in reasonable health, if you give them prophylactic symbiotic of this particular type, you could substantially reduce the risk of sepsis and NEC. So where is the future of probiotic for the preterm infant now? As we said in the beginning, we need head-to-head comparisons of different strains. If you're worried about side effects of probiotics, you could research more on heat inactivated or killed probiotic strains. You could study postbiotics or prebiotics. Definitely for the reasonable number of products currently available for use in preterm infant, we need to have high quality of them. So we need very high standard regulation of the probiotic industry to assure the quality of the product. If you have a high quality product, you need to know how to access them, getting all the regulatory approval. In terms of the future, the primal study is currently ongoing, and in Europe as such, they are studying effect of Infloran on dysbiosis in the gut in babies 28 to 32 weeks. IBP 9414 is basically studying Lactobacillus reuteri DSM 17938 in almost 2,000 babies between 23 to 32 weeks of gestation. So hopefully these 2 trials, by the time I think 2022, the results should be available, and they will help us to guide research and clinical practice. But overall, as of today, we could confidently say probiotics are definitely here to stay. Thank you very much.
I would like to thank Dr. Ramesh Mehta for introducing the speaker, as well as Dr. Sanjay Patole for delivering an excellent talk. His talk has highlighted the evidence-based guidelines for the use of probiotics in preterm neonates, and also stressed that probiotics can reduce the risk and severity of necrotizing enterocolitis in neonates. Now I invite Dr. J.S. Tuteja to chair the next session by Dr. Senthil Sainiappan. Dr. Tuteja is a consultant pediatrician with special interest in teenage issues and is owner of Teens Wellness Center at Indore. He was the chairperson of Adolescent Health Academy of IAP from 2012 to 2015. Dr. Tuteja was the national advisor of Mission Kisarudaya Suicide Intervention Module in 2018 and 19. He has also been conferred with Swati Bhave and MKC Nair Oration Award in 2020.
I am thankful to Dr. Bakul Parikh, Jayan Parikh, President, Indian Academy of Paediatrics, for introducing me. I invite now Dr. Senthil Sainiappan for delivering his much awaited talk. He is working as a consultant pediatric endocrinologist at Alderhead Children's Hospital, Liverpool, since last 6 years. This hospital has sent me a surprisingly to the old pleasant memories. I worked there in Department of Pediatrics as a clinical assistant in 1977. Senthil is a clinical director for endocrinology and has an honorary position as a lecturer in the University of Liverpool. So, Dr. Senthil, please deliver your much awaited talk. Thank you.
Hi, everyone. Thank you so much for this opportunity. It's absolutely fantastic connecting with everyone this way. And thanks for the introductions. I'm Dr. Senthil Sainiappan. I'm working as a pediatric endocrinologist at Alderhead Children's Hospital in Liverpool, UK. I'm the clinical lead for the endocrine department in my hospital. I also work as a honorary senior lecturer in the University of Liverpool. So in the next few minutes, I'm going to cover on how to approach children presenting with short stature. As you all know, this is a common problem, and parents would be appropriately worried about the growth of children if they're not growing very well. And just a little bit of background, looking at the factors that affect the growth. There are 2 main internal factors. One is the genotype or the genetic makeup. So that's derived from the parents. And the second thing is the hormones, like the growth hormone, thyroxine, and the sex steroids during puberty. And the external factors that facilitate the growth includes the nutrition and environment. So an optimal combination of this is essential for children to grow adequately. And that the factors do influence different ways depending on the age of the child. In the first couple of years, the key thing is the nutrition, and also to a certain extent the growth hormone. But subsequently, during young childhood, the main hormones which come into play are the growth hormone and the thyroxine, which help children to grow at an optimal height velocity of what we consider as like 5 to 8 centimeters every year. Subsequently, during puberty, after 10 or 12 years of age, the sex steroids come into play along with the growth hormone that facilitate the growth. So any problem with these hormones at the appropriate age then lead on to problems with the growth. Any chronic disease can affect at any stage of life in children and can cause problems with the growth. So the first of all, how do we know whether the child is short? The key thing is to measure the children accurately using the right stadiometer, and then plot the height and weight on the appropriate growth charts. And what would be also useful is to measure both parents and calculate the mid-parental height. And there is a formula to do that by adding father's height and the mother's height, dividing by 2, and add 6.5 centimeters for boys and reduce 6.5 for girls. And plotting that on the chart will help us to get a predicted height and see if the child's current height is falling within the mid-parental range or not. The other important parameter will be the height velocity, which is again very important, monitored once every 4 to 6 months to see if the children are growing with the right height velocity for their age. Now, plotting the height on the chart is the key thing here, and there are different charts available. For example, in UK, for the first 4 years, we use the UK WHO growth charts, and subsequently we use the UK growth charts derived from the UK data. In India, there is newly available WHO 2006 and IAP 2015 combined charts, which will be useful. So when do we investigate then? Now, once we have plotted the height, if the height falls below the 2 standard deviation, or if the height is crossing 2 major centiles, or if the height is running consistently below the mid-parental target range, then we should certainly think of evaluating these children further for short stature. And that's a broad approach, a flow chart to approach the short stature. So the key thing again is looking at the height velocity. And if the height velocity is normal, then look at, we consider familial or constitutional delay of growth. If the height velocity is low, then look at whether the child has got dysmorphic features. If there is no dysmorphic feature, then look at the weight. If the weight is also low, so if the children are short and they're thin, then generally consider the chronic illness, which could affect both height and the weight. If the weight is on the higher side, but if they are short, then think of hormone problems like growth hormone deficiency, hypothyroidism, and Cushing syndrome. Now, if there are dysmorphic features, the things to look at is whether it's proportionate or disproportionate. If there is a proportionate, consider conditions like Turner syndrome, Russell-Silver syndrome, and Down syndrome. If there is a disproportionate short stature, then we think of skeletal dysplasia, including conditions like achondroplasia. So the initial investigations will be looking for baseline investigations of full blood counts, looking for inflammatory markers, iron levels, kidney and renal function, bone profile, thyroid function. IGF-1, which is the insulin-like growth factor, could be useful as a screening tool. Celiac screen to rule out celiac disease. Looking at the bone age to see how delayed the bone age is compared to the chronological age. And in girls, definitely it's important to do a karyotype to rule out Turner syndrome. And how do we diagnose then further conditions like growth hormone deficiency? This depends on a number of features. The clinical features, again, plays an important role. Looking at the growth data and the height velocity, the hormone levels like IGF-1, and subsequently we do confirmatory tests to confirm growth hormone deficiency using the stimulation test. There are a number of different agents which are used, which include insulin, arginine, glucagon, clonidine. So various agents are used across the country, across the world, to stimulate the pituitary gland to produce the growth hormone, and then they measure the growth hormone and see if they're optimum, or if they're low, then that does suggest and confirms growth hormone deficiency. An MRI pituitary will also be useful to look at the structural changes in the pituitary gland. And once it's confirmed, then children could be treated with growth hormone, which is given as an injection once daily at night time, and that's the starting dose of the growth hormone. And we do train parents to inject the children, and so that this could be done at home. And there are different brands available, and we go by patient choice. And once they start on the growth hormone, then we monitor their height velocity once every 4 to 6 months to see if they're responding to the treatment. And we can adjust the dose of the growth hormone based on the clinical response and by monitoring the IGF-1 levels. It's important to make parents aware of these side effects, which are quite rare, but it's important to be aware of these side effects, including headaches, raised intracranial hypertension, and hairline fracture of the hip bones, which are sort of recognized but rare side effects. Apart from growth hormone deficiency, growth hormone could also be used for other indications which are currently licensed, which includes Turner syndrome, children who are born short or small at birth but subsequently fail to catch up growth by 4 years of age, Prader-Willi syndrome, children with chronic renal failure and poor growth, SOX gene defect. Idiopathic short stature and Noonan syndrome or the indications in certain parts of the world, but those are not like universal indications for growth hormone treatment. So to sum up, it's essential to use the appropriate growth chart when we are dealing with children with height issues. Plotting the height, weight, mid-parental height, and the height velocity are key, and making the right diagnosis. It's important to screen for the underlying diseases, and the common causes include any chronic illness, familial short stature, constitutional delay of growth in puberty, hypothyroidism, and growth hormone deficiency. And growth hormone therapy is available and it's useful when it's used in the right patients. And it's quite important that we start early to get the best outcome for these patients. So thank you once again for giving me this opportunity.
I would like to thank Dr. Jayesh Tuteja for introducing the speaker, as well as Dr. Senthil Sainiappan for delivering an excellent talk. Dr. Senthil has stressed that it is essential to use appropriate growth charts by regularly plotting the height, weight, and mean parental height for monitoring the velocity of growth. The suggestion for using growth hormone early for better outcome is also very well received. Mind you, growth chart is a must for every clinician in his practice. It was absolutely an important symposium, and I am certain that we all have learned the following. First talk conveyed the way COVID vaccine was developed rapidly using advanced digital technology, streamlined the clinical product development plans, and controlling vaccine manufacturing and quality. This has created a pathway for rapid development of future vaccines. The second talk highlighted the evidence-based guidelines for the use of probiotics in preterm neonates and also stressed that probiotics can reduce the risk and severity of necrotizing enterocolitis in neonates. And the third talk, the final talk, said that it is essential to use appropriate growth charts regularly by plotting height, weight, and mid-parental height to monitor the velocity of growth. The suggestion for using growth hormone early for better outcome is always well received. Now I would like to once again thank the chairpersons and the speakers for excellent deliberations, and also extend my thanks to the audience for participating in these deliberations. I am happy to see that lots of questions have been received in the chat box, but let me promise you that we will circulate the responses to these questions after a week's time. Thank you once again. Hope you all enjoyed as much as I did, and thanks again, and we'll request you to join again for the next future GAPIO programs. Thank you very much.